I've been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
This is the video for 3.4, find and use slopes of lines. So this is really just a review of algebra. Slope is the ratio of the change in y versus the change in x. We use the triangle, the Greek letter delta, to represent change in. So there's three different ways to kind of think about slope here. We have change in y over change in x, which is the same as rise over run, which is the same as the difference in the y values over the difference in the x values. So when you have ordered pairs, this last method is the easiest way to do that. Slopes of parallel lines, this is a postulate, okay? Something, again, we do not have to prove. In a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. So if and only if, that's a biconditional. Okay, this means this is biconditional. So this means if two non-vertical lines are parallel, then they have the same slope. We can also say if two lines have the same slope, then they are parallel. It works both ways. And then for perpendicular, in a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slopes is 1. So for example, if I have a slope of 3 over 2, the perpendicular slope to that would be negative 2/3, because when I multiply that, I get negative 6 over 6, which is equal to negative 1. Remember, that's called the opposite reciprocal. This is the opposite reciprocal. Notice in the definitions it says two non-vertical lines, okay? A vertical line is straight up and down. So we're not, in those postulates, we're not talking about vertical lines. And then we have two notes down here. Any two vertical lines are parallel. So if you have lines that look like this, then they are parallel. And then also horizontal lines are perpendicular to vertical. So a horizontal line and a vertical line are going to create a right angle here. Those are going to be perpendicular. Remember, the definition of perpendicular is that two lines intersect to form a right angle. Okay, so in example A, what is the slope? So I have multiple points on this line. Remember, a linear function is a function that has a constant rate of change, which is the slope. So it doesn't matter what 2 points I use. So I'm going to use this point and this point. If you haven't already, you need to copy this graph in your notebook. So take a moment, pause the video, and actually plot those points and graph your line. So the rise is 1, 2, 3, 4. And the run is 1, 2, 3, 4, 5, 6. So my slope is 4 over 6, which is 2/3. We don't normally write our slope as a decimal. We want to keep it as a fraction, just simplified. And if I were to go from here to here, I would see that this is 2 over 3. So as you can see, the slope is the same no matter what 2 points you use. That is a positive slope. So the slope, which we use m, is 2/3. Letter B says, draw a line parallel and perpendicular to line M through A. So the first thing I need to do is find the slope of M. So I'm going to go from here down to here. So the rise is 1, 2, 3, 4, and the run is 1, but I notice that this line is falling from left to right. So my slope is negative 4 over 1, which is the same as just negative 4. A lot of us, though, need to write that over 1 so we remember to do the run and not, ignore the run part. So if the line is parallel to that, then it should have the same slope. So I'm going to draw a parallel line through A. So that means my slope needs to be negative 4 over 1. So I'm going to go down 4 over 1. Down 4 over 1. Or I can go up 4 over 1 this way. So there is my line parallel. So that's my parallel line. Now I want to draw a line perpendicular. Well, what is the perpendicular slope to negative 4? So if negative 4 times what is going to be negative 1? Okay, in other words, what's the opposite reciprocal? Well, it's going to be 1 over 4, and it's going to be positive. So the slope of my perpendicular line is going to be positive 1/4, and that is through point A. So from A, I'm going to go up 1 over 4, or I can go down 1 and to the left 4. And I can do that again. It looks like I have enough points here to go ahead and I'll do one more. So now I can go ahead and draw my line. So there is my perpendicular line through A. So the green is parallel, meaning they never intersect because they have the same slope. And the red line is perpendicular, which because I know that they're perpendicular, now I know that this is a 90-degree angle right here. That is a right angle because those are perpendicular lines. And notice that the two lines that are perpendicular, so the purplish and the red line, they don't intersect at a point that necessarily I had on the line already, but they do intersect at a point. Okay, we have 2 points here and we need to find the slope. So we're going to use our formula, y2 minus y1 over x2 minus x1. So I'm going to call this x1, y1, x2, y2. So y2 is negative 2 minus y1 is 1 over negative 7 minus negative 3. Notice how I put that negative 3 in parentheses. Negative 2 minus 1 is negative 3. Negative 7 minus negative 3 is negative 4. Okay, because that's negative 7 plus 3. Negative divided by negative is a positive, so my slope is actually positive 3/4. Lastly, I just want to remind you of, again, the positive, negative, 0, and undefined slopes. So I've labeled them here for you. I've also got Mr. Slope Guide drawn over here if you need that visual. A positive slope is going to be a line that rises from left to right. We always read left to right. The negative slope falls from left to right. A 0 slope is a horizontal line. Just to remind you, the equation of this line is going to be y equals negative 4. And the equation of the undefined, the line with the undefined slope, is going to be x equals 8. So just to remind you about that, we'll be talking more about equations in the next section, but just a reminder about that. Make sure you know the difference in the slopes.
I've been waiting way too long. Yeah.